So last day, we started learning about stoichiometry. And what is the key idea about stoichiometry? Stoichiometry allows you to convert what unit to what unit? Moles of A to moles of B. So anytime you are doing a stoichiometry problem, so for this whole freaking unit, you are going to be, step one is going to be find the moles. Ooh, I forgot to write one. Step one, find moles. Step two is also find moles. Now that sounds a little bit redundant, but in the first step, you're finding moles of substance A. That is the substance that you are given in the question. All right, in step two, you're finding moles of B, which is your unknown, whatever has the question word. And last day, we went from mass to moles, and then we went to moles of the other substance, and then we could convert that into mass. Today, we are going to be reviewing the concept of solutions. And when we're dealing with solutions, what is the conversion factor for solutions? What is the conversion factor for solution that involves moles? Nobody knows? Well, I'll give you a clue. One of them is moles, because we got to find moles. What's the other part of it? Liters. Yep. So the solutions conversion factor is moles per liter. How would you often see this written in a question? Capital M. Okay. So today, in our little chart here, we're going to be focusing on the middle section. So we'll be going from the volume of solution A to the moles of A, and we will use molarity to do that conversion. That'll be your moles per liter. And then, of course, to go from moles of A to moles of B, we use the mole ratio, which is the moles of A over the moles of B, or B over A. Where do we get those numbers from that we use in this one? That's from the coefficients. In the reaction. I don't have room to write balanced reaction, but that should pretty much go without saying that if you're going to be doing this, your reaction must be balanced. Okay? So that's step one, use molarity. Step two, you're going to use the mole ratio. And then step three, if we're finding the volume of the solution, we'll use molarity. But we could just as easily ask you for the mass of substance B or the number of particles of B or something like that. Okay? So let's try an example. Remember, always rewrite moles as moles over liters. Most of you are getting really good at that by now. And all volumes have to be in liters so that they work with those liters. So if we give you milliliters, convert to liters. Okay. So I'm just going to grab this question here. And if you want your own paper so you can follow along, you can do that, or the question is written in your book, obviously. So we have H2 gas is produced by the reaction of, we have phosphoric acid. Remember ic acids? What kind of ions make ic acids? 8s. So that would be phosphate. And phosphate is PO4 3-. So how many hydrogens would we need to go with that phosphate? We would need 3. So it's going to be H3PO4. So we have H3PO4 right there. And we mix it with some chromium. All right. And actually, I'm going to do this. I'm going to move that over there. Let's take a look at that reaction. And you guys are going to tell me what type of reaction is that? Yes, that is a single replacement because you have an element and a compound. Who will the chromium replace? Chromium will replace hydrogen because chromium is going to become a positive ion and hydrogen is the positive ion. Positive has to replace positive. And you can see that's exactly what happens. The chromium ends up with the phosphate. And I guess it's chromium 3 phosphate. And there's our balanced reaction. And we are told that this substance here, we have 118.5 milliliters. What should we do with milliliters? Turn it into liters. So that would be 0.1185. Don't forget you move your decimal place 1, 2, 3 paces to the left when going from milliliters to liters. And we are also told that we have 0.8775 molar. So we are going to rewrite that as 0.8775 what? Moles per liter. Okay. So this is moles of H3PO4. In stoichiometry problems, you should always have a substance after the word mole because you're going to be changing from moles of this thing to moles of that thing. So you never just want to say moles because I'll say to you, what do you mean moles? Do you mean moles of chromium? Do you mean moles of phosphoric acid? Do you mean moles of H2? Do you mean moles of chromium phosphate? Which one are you talking about? And you're going to change partway through. So you have to have that. So you must have the chemical formula after moles. Because you're going to have moles of this thing and then moles of that thing, and you need to distinguish between them. This is our given information. That's what we're given. So we are given information about H3PO4. So our step 1, we're going to take our liters and our moles per liter of H3PO4, and we are going to find, what are we going to find? Step 1 is always find the moles. So we're going to find moles of H3PO4. Then we need to look at our question and say, what is being asked for? We are asked for calculate the moles of H2. That means that H2 is our unknown. So that is substance B. Okay? The thing we are given is substance A. The thing that is our unknown is substance B. So now we are going to step 2. Remember, step 1 is find moles. Step 2 is find moles. And this time we're going to be finding moles of B, which is, whoops, that was supposed to be a highlighter. Moles of H2 gas. We're not asked for anything else. It says moles of H2 gas. So at that point, we're going to be done. If they asked us for grams, we would have to do a third step. If they asked us for volume, we would have to do a third step, but we don't need to. We just need to find moles. So let's do the math here. How many moles of H2 can we get from 0.1185 liters of 0.8775 moles of H3PO4 per liter. Step 1 is done. Step 2, we want to go from moles of H3PO4, so that needs to go on the bottom. And we want to find moles of H2. So where do we get these numbers from? Those come from the coefficients. Let's go find those. H2 and H3PO4. H2 has a 3. H3PO4 has a 2. Toss that into our calculator. .1185 times 0.8775 times 3 divided by 2 equals 0.15598 moles of H2. How many sig figs? You guys are the regular firecrackers of my day. 4 sig figs. 1, 2, 3, 4. There we go. So that's going to become 0.1560 moles of H2. Step 1, find moles of your known substance, A. Step 2, find moles of your unknown substance, B. Always the same. Let's try a second one. This question is on page 16. What volume of 3 molar NaOH? So what I'm going to do is I'm going to write, I have 0.300 molar NaOH, but it asks me what volume. So I'm going to say, I don't know how many liters of NaOH, because there's my question word. The other number that I am given is 56.8 grams of sulfuric acid, H2SO4. Which of these two things is our unknown? Is it NaOH or is it H2SO4? I'll tell you, whatever has the question word. And that refers to your NaOH, whichever has the question word, that is your unknown. That is substance B. And that makes sense, right? Because we're not wondering about H2SO4. We're not like, how much do we have? There's nothing we don't know about it. We know we have grams. If we needed to find moles, we could find moles. So that means that our known substance is the H2SO4. So that is substance A. And remember step 1. Tell your partner, what are you finding in step 1? It's always the same. Are we finding elephants? No. Are we finding liters? No. I know you got your hand up. Are we finding particles? No. What are we finding, Jay? We're finding moles. Always find the moles. Step 1, find the moles. What are we finding moles of? We're finding moles of which substance? Substance sulfuric acid, substance A. Always A. You're known. Step 2. What are you finding? What's the unit? Find moles. And this time, what are we finding our moles of? Substance B. That's our unknown. So what we're going to do is we're going to start with our known. Here's our map. We're going to start with 56.8 grams of H2SO4. H2SO4 is A. We're going to convert it into moles of H2SO4. That's A. Then we're going to find moles. See, we found moles, step 1. Step 2, we're going to find moles. This is moles of NaOH, which is our unknown substance B. And then finally, we are told that we want to find liters of NaOH. So we need step 3, we're going to find liters of NaOH. So we're going to have a 3-step problem. So, how many liters of NaOH? And we're starting with 56.8 grams of H2SO4. How do we go from grams? How do we go from grams to moles? What do we use? Yes, we use moles per gram, but what do we call that? Molar mass. Beautiful. Okay, so we've got our grams down here and our moles up here. The molar mass of H2SO4 is, let's see, 2 times 1, and we have 32.1, and we have 64. So that is 116.1. 116.1 grams per mole. What have I done wrong here? I've done something wrong. Yes. I didn't mention the name. I left moles and I didn't write what I have moles of. And remember, that's going to be changing, so I need to say what I have. So that's moles of H2SO4. And that's important because in our next step, we're going to have moles on the bottom and moles on the top. And if we don't tell which one's which, you'll be like, it's just so confusing. So on the bottom has to go moles of H2SO4, and on the top has to go moles of NaOH. And I'm running out of room, so I'm on my, maybe I can just make it smaller. So my grams cancel out, my moles of H2SO4 cancel out, and I need to now cancel my moles of NaOH and find my liters. So far, I've not put in any numbers. What numbers do I need for my mole ratio, NaOH and H2SO4? Let's go back to our question. Oh no, what's missing? In order to know the ratio between moles, I need a balanced reaction. So let's put these together and balance it. There probably is a reaction in your book, but your test is tomorrow, so you might as well predict the products and balance this by way of practice. What type of reaction is this? Tell your partner. This is a review for tomorrow's test. What type of reaction do you have here? H tells you that you have an acid. It's not enough to just have an acid. You must also have a base in order for that reaction to be neutralization. Would anyone like to see how to predict those products? Nobody? You're all good at it? You would like to see? Okay, good. Even if there's one person, what that means is that there's like 17 other people who are too shy to say they would like to see it. So what we do is we say, okay, I've got H plus ions and I have SO4 ions. I have Na plus ions and I have OH minus ions. And just like in a double replacement reaction, I am going to take my outside ions, which are going to be positive and negative, and combine them. That's going to give me HOH, which is water, but I'm going to leave it that way for balancing purposes. And then I'm going to take my other positive and my other negative and combine them, making sure that the positive comes first and the negative comes second. So that's going to be Na2, because we need two of them because there's only a one positive there. Na2SO4. 4. And once you've done that, you have the correct things you need to balance the reaction. So we would need 2 NAs, 2 NAs. That gives us 2 OHs, which means we need to put a 2 there. And we also have 2 hydrogens, but there's 2 hydrogens here, so we're all good. And now we know that it is a 1 to 2 relationship between H2SO4 and NaOH. So there's a 1 in front of the H2SO4, and there's a 2 in front of the NaOH. We use up 2 moles of NaOH for every 1 mole of H2SO4. And remember, moles per liter is molar. So we have 0.300 moles of NaOH per liter. Okay, that's our 0.300 molar NaOH, which means that for every 1 liter, we have 0.300 moles. Throw that into our calculator. 56.8 divide by 116.1 times 2 divided by 0.3 equals 3.2616. And that's going to round to 3 sig figs, it looks like. Yeah, we got 3 here, we got 3 here. Do these have significant figures or are they infinite? 2 NaOH for every H2SO4. I feel like I'm just talking to myself and for like the 4 people who are paying attention. I don't know what the rest of you all are doing, but are those exact or inexact? They came from here. So those are counting numbers. There's 1 molecule of H2SO4 for every 2 molecules of NaOH. So those are exact numbers. Okay, mole ratio always has exact numbers. So our smallest number of 3 sig figs is, of sig figs is 3 sig figs. So this should round to 3.26. And what unit are we left with here? We are left with liters. And that's what we wanted. And that's liters of NaOH solution. Okay. Question. Do you want a third example? Or do you want to just try? Option A, third example. Option B, try. Okay, I got like 3 people voting for try, 4 people voting for try. Nobody voted for the other one. The rest of you, I assume, are just, I don't know what you're doing, but you're willing to go with the crowd, so you're just going to try. So we're going to go to the exercises, which is on page 18, and you're going to give some of those a try. Okay? And the small answers are on page 19. The worked answers are in the key. Okay? Page 18 and 19. Yes, absolutely. So you want the rounds from that. Okay. So step number 1 is fine, but you already have it, so that's fine. So this is moles of A. Now you want to go from moles of A to moles of B. Who is B? B is, has a question. What out of moles of CO2 to moles of NGC. So, yeah. Yeah. Put in your units to start there. Yeah. Yes. Yeah. Mass. Yeah. Yes. Yeah. Okay.
It's like when you see it's really nice. Every time you see it, what I do, I just use where
So pages 18 and 19 is what you're working on.
when you see it,
Yes. You need to balance the equation first. How do you do that? Okay. So who's reacting? Zinc and yes. So plus is yes. Say to yourself, what kind of reaction is that? Where you have one synthesis, the only kind of synthesis I want you to work about is elements and elements. Because an element is like a any reaction an element. Yes. Yes. So who will zinc take the place of? Yes. Yeah. Yes. What do you know about hydrogen? Yeah. Start by writing some balance reaction. So that's for like the last part. Your top reactions. Elements. Okay, we have synthesis. Only one function, that's it. Single place. Element. Yes. Except that. So visualization varies. And now we have the foods and guys. Charges. Okay, so who is your known substance? Who do you have information about? Hydrochloric acid. So your step one is to find moles of hydrochloric acid. We don't know why, but if it says leader, it's not leader. It's not leader. So now we have to, what's that? Yeah, HCl, so you put HCl. And. We're gonna get you okay.
Issues.
Yeah. Yes, it's down. Yes. Okay, so now you have moles of HCl. Want to turn that off? Yep. Yeah, you got it. Okay. So we're actually doing this tomorrow.
Yeah, thanks.
Yeah. Oh, yeah.
It's like the minus one.
Plus stage. Stage you got it.
Sorry. So you know, once you start on it, you know you get to.
Yes. Yep. Yes.
Wait,
Yes.
the ratio to the.
Yes. 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 No problem at all. Oh, and exercise just needs to have more. So you take, because you don't have to worry about phosphate, but lots of phosphorus.
Yeah, so.
Oh, the charges. Yeah.
It's just like.
Yes.
All the
Actually, very tough. That one.
Trying to
Almost.
close it.
Second one, following
Back.
the
Third.
Yes. Balance. Okay.
I two points. Two. Yeah.
So that will be.
Yeah.
Yes, person. So yes, you're one.
You're not dying?
Asking.
Yes.
At least divided.
No,
Oh, yeah. Well,
Yeah. So you are decomposing sodium nitrate, you're making oxygen and Na. Yeah, so Na. Or sorry, sodium nitrate. Yeah. Yeah. Metals are always gonna be solid. Okay, and then sodium chloride is soluble, so that's gonna be, yeah. But it's, that's okay. Yeah, okay. Yes. Yes.
Oh,
Yeah, you did. Yeah. Okay. Yeah. How are you doing? You're very proud of Hi, how you doing? You're good? That's great. That's actually a really good way to learn.
Yeah.
Yeah, it seriously is.
But yeah, it's just the same things I did.
Good?
That will change.
Okay, okay, so these. So one little thing that is alcohol on basis out of several reactions. From low age. You can ask this, so we're good to go. Oh, actually, I'm not I'm sorry, that's so. Yeah, perfect. You really are. Oh, and you know what? That's the way to be. Yeah. Hi, today. Yeah, yeah. Yeah. I found it. And I just had this question. Hydration is a little bit much. If you're like, I don't want to really think about hydration right now, and I'll wait on that. Soon. It's pretty soon. Yeah. Yeah. You just like.
We need a sign. I'm so sick. Yeah, exactly.
Just like
Honestly, I was so close. I was so close. Like crap. I was there first.
Oh, yes.
And all of them, right? Yeah, right. Everyone's They not provide their you want to wait for it to I heard you all this. No, I'm not sure if this. But you know, we see. Yeah, and they can not like. Right, and how. Yeah, and it does not get done very well. Maybe solve it. They also just like just try to graduate all the colors they were so excited. I was like watching them after that run and absolutely fighting over there looking at their the wall. I'm like, guys, we're like 15. Learn. I like it. I can't. And some of them are like, like, how am I it's like, you know, like, right? My mom was like 8th grade. I looked at my lovely daughter, so before her and I was like 16 years old. And I was like, why are they all just so pleasant and sweet? And you're like, oh my gosh, you're so lovely. It's so nice to be around them, and then I just felt it. He's like, oh, hey, in my blue single file. You're 12, but you're trying to go no big person line. That's so crazy. Yeah. And then just off you go. And then they look after the goats, bring them back and chase after the goats. And then 2 years later, they come back and they're ready to fight. Or like a while, it was like, for and he's just and he said, I'm looking forward.
I think we are.
And I was like, oh my God, you're just
Right, that's just like, oh.
Like, I'll get my mother. Oh, I do. Like.
Yeah. Oh, no. If there's just a case.
Oh, yes, you talk about like. Okay. Start, right? Never mind. Acid. It would be. Okay, so this one, how many grams of calcium phosphate? Why didn't it use that product? I got it in the reactor. Yeah, so you have to make from the reaction of this and this, you actually have to make like say, this is you have to, yeah, I know. This is okay. Yeah. And you're okay with this friend. Okay, excellent. Yeah, exactly. So you remember when I said we don't have everything? All reactions, balancing, yeah.
So folks, we've got 10 minutes left right now. I know that our test is tomorrow. So for homework, the homework is really due on Friday, because if you just spend tonight, studying for your test, that's great. But I know how many of you forget to look at anything after the test because your brain's like, oh, I just spent so much time thinking about everything and I just got nothing left. So I'm letting you know this is tomorrow night's homework, okay? So you can work on however much of it you want to today, and then that'll be for homework for tomorrow, okay? And we still have 10 minutes left right now, so don't assume that when I said that class is over. It's not. Okay, keep going. Yes. 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 Little graphs and stuff. Yes. So like that. So we have. Balancing. Yeah. Yes. No. Okay. Oh, so you're like, oh no. Yeah, like, so it was, like, not when you're balancing and then I woke up at 3:30 this morning and I could not fall back asleep again. So by 4 o'clock, I'm like, fine, I'll get up, do some more. But like it wasn't very efficient because like my brain's still there. Yes. Now, to be fair, I usually get up at like 5:30, so it wasn't like that early compared with, you know, if you were getting up at 7:30, that would be that way early. It's still early. But you know, the birds are ready to chirping, the sun's up, and I'm like, oh, I wear a sleep mask though. What's up by 4? Yeah. Yeah, it's like,